Hello everyone, welcome back to our next lesson in conic sections. Today we're going to be starting on page 32, and this is actually a very short piece. This is called mixed practice. Now that you've seen the equations of the four different types of conic sections, and I'm hoping that you can use the characteristics of those equations to tell them apart. What they're doing here is they're giving you equations kind of mixed up. That's why I guess it's called mixed practice. Would you be able to look at the equation of one of the four conic sections, and would you be able to determine which of the four that it is? And once you've done that, can you just pick out some of the information that they're asking you to do right here? So let's see what the question says. Now this is about halfway down page 32. Describe the curve represented by each equation. In other words, what is it? What kind of a curve is it? Identify the type of curve and its center if it's a circle, ellipse, or hyperbola, because remember, those three conic sections really do have a center, or its vertex if it's a parabola. Okay, now remember that actually hyperbolas and ellipses also have vertices, but they're only asking for the center if that's the case. So let's look at these individually. And remember now the different characteristics that they have. Let's look at A right here. And now if you're asking yourself what kind of a conic section this is, you can see that the y is squared, but the x over on the right hand side is not squared. Now, what kind of which of the four conic sections had that characteristic, that only one of the variables was squared? Well, if you think about it carefully, and if you go back and look, this was the first type that we looked at. This was actually a parabola, all right? That's the defining characteristic of a parabola, is that one of the variables is squared and the other one is not. Well, because it's a parabola, now they want us to say where the vertex is located. And getting the vertex of a parabola is no more difficult than getting the center of any of the other three conic sections. So look at what's behind the x first. You always do that anyway. And I can see I have x plus 1 over here on the right side. Well, then my vertex would be the 1, but with the sign change. So that would become -1 for my vertex. And then you look behind the y and you see what's added or subtracted there. And we have a takeaway 2, subtract 2. So that tells me that the y coordinate of my vertex is +2. So there's our vertex. And if you were going to describe what's going on here, well, I guess probably the only thing you could say is which direction will this parabola open in? Remember, they can open up or down or left or right. And I can see here that it's the y that's squared. And when the y is squared, recall, like I was telling you in unit number 2, it's not going to be a function, which means that whatever this is, it fails the vertical line test. And I guess that means it opens either left or right. And the fact that the constant in front of the linear term, the x, remember we were calling that 4p when we did parabolas, it's positive, and I guess that means that this parabola opens in the positive direction, which for our case would be to the right. So there you go. There's a description of the first conic section. And let's do the other ones now. Let's look at these. And like I say, we're going to try to tell what they are and find the center or vertex and maybe just a little description as to what's actually going on there. So if we look at the second one, now look at it very carefully. I can see that the x is squared, okay, and I can see that the y is squared. So it's not a parabola. I can see that in the center they're added together. So it's not a hyperbola. It's either a circle or an ellipse. Well, do you notice that the form this one is written in is equal to 1? Look at your two denominators here. Now I notice the y minus 1 squared. It doesn't look like it has a denominator. Well, actually it does. You can put that over a 1. And so your denominators are different. And that means it's not a circle. Even if those two denominators were the same, then it would definitely be a circle. This, ladies and gentlemen, is an ellipse. This is definitely an ellipse. And of course, an ellipse has a center, so we can say where the center is, and that's easy. The center, you look at, again, behind the x, you have x plus 4, so the center starts with negative 4, and the y, behind the y, you have y subtract 1, so positive 1 would be the y coordinate of your center. And if it's an ellipse, I guess the only thing then that you could do to actually describe it would be just to say in which direction is it elongated. Is it stretched out or elongated horizontally, or is it stretched out vertically? Well, remember, that's got to do with where your a squared is located. And for an ellipse, the a squared is the larger of the two denominators. Well, look at that. There's your a squared. 4, right? 4 is bigger than 1, obviously. And so this one would be stretched horizontally. Okay. All right, so that one is stretched out horizontally. Or if you want, elongated horizontally, whichever way you want to say that. So let's look at C. What do we have there in C? Well. All right, I can see the x is squared, and I can see the y is squared. So it's not a parabola. I look at the sign that's in between them, and this time there's a negative in between. So one of the terms is positive. The first term is positive. The second term you can think of as negative. And there's only one conic section that has all of that. That is a hyperbola. Definitely a hyperbola. And we can talk about the center of a hyperbola. And it's just the same as finding the center of an ellipse or a circle. You have x minus 1, so it starts with positive 1, and then we have y subtract 2, so the y coordinate of the center would be positive 2, and there's your center. And I guess the only way you could really describe a hyperbola, remember they can open up and down, or they could open left and right. And this one, let me see, it's the x term that's positive. The x squared term is your positive term. And that tells me that it's going to intersect the x-axis in a couple of places. All right. It might intersect the y-axis, but we're not quite sure. But it's definitely going to intersect the x-axis. And in fact, what happens here, this one is going to open left and right. Okay, and there's one more. One more to do right on the bottom. 4 conics, 4 questions. Oh, I wonder. Here's D. We have x plus 4 squared plus y minus 2 squared equals 25. All right, now the fact that like an ellipse and a hyperbola was usually equal to 1, that might be a hint, but not necessarily, because remember, you can always turn the right-hand side into 1 if you wanted to anyway. But I notice the x is squared, and I notice the y is squared. So it's not a parabola. I can see there's a plus sign in between. They're both positive, in other words. So therefore, it's not a hyperbola. And I don't see a denominator there, but you can put them in. You can think of two denominators equal to 1. Well, that means they're the same. Even if the numbers were in front, even if they weren't denominators, if they were coefficients of the x squared and y squared term, as long as they're the same, ladies and gentlemen, we have a circle right there. Okay, we have a circle. And let's see, what's the center of this circle? Well, the center, again, same way you found the centers before, x plus 4. So it would start with a minus 4. And then I have y minus 2, so that would end with a positive 2. There's your center. And I don't know about describing it. I suppose you could give the radius for a circle, but circles are nice and round. So the radius r is equal to, well, you look at the number on the end, 25. So it's the square root of that number, and the radius would be 5. And anyway, that's all there is to this, really. Just a very quick idea of looking at the equation, telling what it is, and perhaps giving a little bit of information about the shape, okay? So anyway, that's it for this section. Now, when we start The next section on page 33, the same thing is going to be true about telling what shape you're going to get from the equation of the conic section. But now the equations are going to be somewhat different, okay? They're going to be in what's called the general form, the general second degree equation. So we'll start that in our next video. All right, so I'll end this one here. Bye-bye for now.